the linear programming graphical method. So what is graphical method? Owing to the importance of linear programming models in various industries, many types of algorithms have been developed over the years to solve them. Some famous mentions include the simplex method, the Hungarian approach, and others. Here we are going to concentrate in one of the most basic methods to handle a linear programming. There are most commonly used terms in linear programming. The first one is objective function. The objective function is the direct function of form z equals ax plus by, where a and b are constant, which reduce or enlarge is called the objective function. For example, if z equals 10x plus zy, the variables x and y are called the decision variable. The second term is the constraints. The constraints is the restrictions that are applied to a linear inequality are called constraints. There are non-negative constraints, which is x greater than y and y is greater than 0. And general constraints, x plus y is greater than 40. And the third one is the optimization problem. It is a problem that seeks to maximization or minimization of variables of linear inequality problem. It's called optimization problem. And the fourth one is the feasible region. A common region determined by all given issues, including the non-negative x greater than or equal to 0 or y is greater than or equal to 0. Constraint is called the feasible region of the problem. The region other than the feasible region is known as the infeasible region. And the fifth one is the feasible solutions. These points within or on the boundary region represent feasible solutions of the problem. Any point outside the scenario is called an infeasible solution. So our first example of the graphical method. So the next constraint is 25x plus 50y less than or equal to 1000. Or in other terms is, in simplest term, x plus 2y less than or equal to 40. Also, x greater than 0 and y greater than 0. So our next step is to create a graph using the inequality. So our first graph. So after we compare the intersection point of the graph to find the maximum number of cakes that can be made, so clearly the z is maximum at coordinate 20 and 10 here. So the maximum number of cakes that can be baked is z equals 20 plus 10 equals 30. So that's the first example. So the second example for the graphical method of linear programming is this. Half the perimeter of a rectangle garden whose length is 4 meters more its width is 36 meters. Find the dimensions of the garden. So the first step is let x be the width of the rectangular garden. So let x be the width of rectangular garden. And let y be its length. So y equals x plus 4. And And half the perimeter of the rectangle garden is 36 meters. So perimeter of rectangle is 2 equals 2 times length plus base. So length plus base equals 36 and y plus x equals 36. So y equals 36 minus x. Now let us find the x and y intercept to draw the graph. So first graph. So first graph is y equals x plus 4. And the x-intercept equals y equals 0. Let us put y equals 0. So x plus 4 equals 0. Let's transpose x equals, the positive 4 become negative 4. So the point is negative 4 and 0. And it's y intercept. Let's put x equals 0. So y equals 0 plus 4 equals y equals 4. And we have 0 and 4. So that's the first graph. And the second graph, for the second line is y equals 36 minus x. So let us put y equals 0 and then x-intercept. So put y equals 0. So 36 minus x equals 0 equals x equals 36. So our point is 36 and 0. So let us now put the x equals 0. So y-intercept. So put x equals 0. So y equals 36 minus 0 equals y equals 36. So our points are 0 and 36. So let's proceed to the graphing. So the above lines are intersecting the point is 16 and 20. So length of the rectangular garden is 20 meters. And the width of the rectangular garden is 16 meters. So the third example is, the path of highway number 1 is given by the equation x plus y equals 7. And the highway number 2 is given by the equation 5x plus 2y equals 20. Represent this equation geometrically. So the first step is, we have x plus y equals 7. X plus y equals 7. And let's transpose this to x to y equals 7 minus x. And the second one is 5x plus 2y equals 20. So transpose it as y equals 20 minus 5x. So in tabular form, the first one is x, y, and points. So x is 1 and 4, and y is 6 and 3, and the points are a, b. And so after we plot the points, so this is the graph. So example number 4. The word problem is, a A father tells his daughter, 7 years ago, I was 7 times as old as you. You were then. Also, 3 years from now, I shall be 3 times as old as you will be. So represent graphically. So first, let the present age of the father be our x years, and that daughter equals y years. So 7 years ago, father's age is x minus 7 years. And then 7 years ago, daughter's age represents y minus 7 years. So according to the problem, x minus 7 equals 7 and y minus 7, or x minus 7y equals negative 42. So according to the problem, after 3 years, father's age equals x plus 3 years. And after 3 years, daughter's age equals y plus 3 years. So x plus 3 equals 3 times y plus 3, or x minus 3, y equals 6. So after we plot all the points, this is the graph. And the intersecting points are the 42 and 12. So after we plot all the points from A to D, we come up with this graph. So the point A is 0 and 10, which is here, and the point B is 8 and 2, which is here. And the next letter is point C, which is 0 and 4, and the point D is 1 and 5. And lastly, the point E is 3 and 7. So as you notice that the points A and B intersects the C and D, and they intersect at a point E, which basically means that the x is equal to 3 and the y is equal to 7. So we conclude that the number of boys is equals to 3 and the number of girls is equals to 7. So that's all. Thank you.